All right, rolling along with more volume. This time, pyramids and cones. Kind of broke it down. Prisms and cylinders last time. Pyramids and cones this time. There's the formulas for a pyramid and a cone. Very similar to prisms and cylinders. If you remember a prism, okay, a prism was just BH, and a cylinder was pi r squared h. So basically a cone is just 1/3 of that, and a pyramid is just 1/3 of that. Okay, so 1/3 BH, 1/3 pi r squared h. Why? Because cylinders and cones are very similar. A cone has a circular bottom, right? It's just like a cylinder, except instead of having two circles, it just comes to a point. And then same thing for a pyramid. Okay, it's almost like a prism. You could have a square or rectangle or whatever the base is, but instead of going to another square or rectangle, it just goes to a point. Okay, and we've talked about these in the past. So it should make sense that the volume of a pyramid would be much smaller than a prism, and a cone would be much smaller than a cylinder. It turns out that it's 1/3. So basically, divide by 3. Okay, multiply by 1/3 is the same as divide by 3. So some examples here with these formulas, and these are all given to you on the reference sheet again. So determine the volume of the cone shown below. Now, so for the volume of a cone, we do need to do 1/3 pi r squared h. The problem with this particular cone is that we don't know the radius. The height is 11. See, but we don't know the radius. But the radius of the cone is simply, if you take a look, there's a right triangle. And and look what they gave us. They gave us the slant of the cone, which was this, and they gave us this piece here. So think of a right triangle, right? If you know two sides of a right triangle, how do you find the third side? Pythagorean Theorem. So we do need Pythagorean Theorem, which is also on your reference sheet. And we'll call this R. So it's going to be, this is the C, ABC, right? A squared plus B squared equals C squared. Again, that's because we got to find the radius. A will be, what is this, 11? Yeah, okay. So 11 squared plus, and then we'll call that R squared, and then radical 137 squared. Don't be scared by the radical, because when you square the radical goes away anyways. So this is going to be 121 plus R squared equals 137. Subtract 121, and you get R squared equals 16, and then of course you take the square root, and R is 4. So there's our R. We could put that in there, and now we can find the volume of our cone. 1/3 pi r squared times 11. Oh, wait, 4. Why did I put R in there? That should be 4. Sorry about that. Okay. And so it's 16 times 11 times pi times 1/3. It comes out to be 176 pi over 3. I'm just going to leave it in terms of pi, because it says give an exact answer. So we want to leave it in terms of pi when they want an exact answer. Because if you put that in your calculator, you'll get a decimal approximation. It'll do 176 times pi and then divide by 3. You'll get some decimal, but then you have to round it off. The calculator rounds it off because pi is irrational. So at some point it rounds it off. You want an exact answer. That's telling you to leave it in terms of pi. So 176 pi over 3. Find the dimensions of a cone that is similar to the one given above. So a similar cone, and we talked about this before, all you have to do is have some kind of ratio, right? So we're going to just multiply the radius and the height by 2 or 3 or whatever. So let's just make a new cone. All right, so let's say the new cone is double the height and double the radius. So let's say R is going to equal 8 now, right? And then the H is going to equal 22. If we double the radius, we'll double the height. Okay, so explain how you found your answers. I'll just say I doubled, or we doubled the dimensions. Okay, so we just doubled the dimensions. And again, you could have tripled them. There's more than one answer. You could have had 12 and then what, 33? all right, or whatever, times 4, times a half. You can make them half as small, whatever you want to do. All right, now calculate the volume of the cone you described in part B in 2 ways. First, use the volume formula, and then use the scaling principle for volume. So this is good practice here. So we're going to use our volume formula. So it's 1/3 pi r squared h. 1/3 pi r is 8. 8 squared times the height is 22. And that comes out to be 1408 pi. Here, I'm going to go like this. 1408 pi over 3, to be exact. Now, the scaling principle is going to use the fact that we did a couple lessons ago, where you just take that ratio, and it's a 1-to-2 ratio, so 1 to 2, because we just doubled it, right? We made 4 to 8, right? 11 to 22, 1 to 2. So it's a 1-to-2 ratio from the original cone to this cone. It's a 1-to-2 ratio, and we're going to raise to the 3rd power. All right, that's how you do volume. How you figure out volume, you just cube it. All right, and then we already know the smaller volume was 176 pi over 3. We did it right here. So I'm just going to put 176, and then we'll just put the pi over 3 back in at the end. So we'll go 176 over x. Okay, so this will be 1 over 8 equals 176 over x. And then multiply 8 times 176, basically. And that gives us 1408. Okay, and then again, we left that pi over 3 off. So we got to put that back in. 1408 pi over 3. All right, so you could see how you could actually find the volume using that scaling principle if you know that they were doubled. That's just more practice with that scaling principle. All right, example 2, a square pyramid has a volume of 245 cubic inches. The height of the pyramid is 15 inches. What is the area of the base of the pyramid? So I'm going to draw this out here. I'm going to draw a square pyramid. So there's a square, and then we just draw from that tippy top to all the corners. The base is, the height is 15. So I'm just going to do that here. I'm going to do it on the side because it's kind of hard to see if I mix it in there. So the height of the pyramid is 15. The volume is 245 cubic inches. I want to make sure I'm inches, cubic inches, so I'm using the same units, right? What is the area of the base? Well, I know that my formula is base area B times H, base area times height, and then 1/3. I'm sorry, I should just write that out better. So volume is 1/3, because it's a pyramid. Base area times height. So I know my volume, 245. 1/3. I don't know my base area. I'm trying to find my base area. I know my height is 15. Okay, so I'm trying to find that base area, the area of the base right there. All right, so we're solving an equation. What could you do here? You could divide by 15. You could multiply by 3. I'm going to multiply by 3 just so I avoid fractions. That cancels out the 1/3. That gives me 735 equals 15b. B15 is the same as 15b. And then divide by 15. All right, so B equals 49. Okay. So my base area is 49. Then they want us to find the length of one side of the base. So if the area of a square, is 49, all right, well, just take the square root, because you'll find what times what. It's x times x, right? I don't know the sides. What times what gives me 49? So 49 equals side squared, and then just take the square root. S equals 7. All right, so each side must be 7. 7 times 7 gives me the 49. You got to think about what a square is. All right, example 3 here. Gold has a density of 19.32 grams per cubic centimeter. If a square pyramid has a base edge of length 5, height of 6, and a mass of 942 grams, that's cool. Is the pyramid in fact solid gold? Ooh, Is it solid gold? All right, so we need volume. We know the density. All right, we know density. If we could find volume, then we could find the mass. All right, so we're going to do volume. 1/3 base area times height. Now it's a square. So the base area is side squared times height. And the side, its base edge, I could draw a picture if you want. Same thing, it's a square pyramid. Base edges are 5, and the height of the pyramid is 6. All right, everything's centimeters and grams, so we don't have to worry about converting. The sides are 5, so it's 5 squared, and then the height is 6. 25 times 6 divided by 3 comes out to be 50. So my volume is 50. Now I'm going to check my density. Density equals mass over volume. All right, density is 19.32. I'm finding the mass, and my volume is 50. So I cross multiply that out, and it comes out to be, oh, no, gold, I'm sorry, that's wrong. Forgive me. Not reading this correctly. So the mass is 942. That's what we're given. The mass is 942. The volume is 50. The density is 18.84 grams per cubic centimeter. Okay? The density is 18.84 grams per cubic centimeter. But gold has this density. They're not saying that the square pyramid is gold. They're asking you if it's solid gold. But if it was solid gold, this should have come out to be 19.32. So is this square pyramid, is it solid gold or is it mixed with something else? And as you can see, because it did not come out to be the same density, we must be determined that it was mixed with something else. So it is not solid gold because density equals 18.84, not 19.32. All right, and then to answer the question, I'm not going to write it all out, but what reasons could it be? It could be mixed, right? It could be mixed, or it could be hollow. Maybe it's a little bit hollow on the inside. You don't know if you can't see the inside. It could be hollow. All right, so it's just doesn't have the same density. So since it doesn't have the same density, it must not be solid gold. All right, so these are all real-life applications of volume for pyramids. This is kind of stuff you might see on your exam at the end of the year. All right, I'll see you in class for more practice on volume of pyramids and cones.